Section 3, Video 6, Network Adapter Types and Virtual Switch Policies. There are a number of network adapter types that are available and supported with VMware. VMXNet is a high-performance 1 gigabits per second network adapter that operates only if the VMware tools have been installed. As we know from previous slides, it's best practices to install VMware tools as soon as a VM is provisioned. The VMXNet adapter shows up as flexible in the VM properties. Another adapter, which is VLANs adapter, is a 10/100 megabits per second slower network adapter, widely compatible with a range of operating systems, and is the default adapter used until the VMware tools is completed. E1000 adapter is another network adapter that emulates the Intel E1000. It's a 1 gigabits per second network adapter and most commonly used in 64-bit VMs. Finally, we review VMXNet 3, which is the next generation, called Para-Virtualized Network Interface Adapter, designed for high performance, supported only for virtual machines with version 7 and higher, with a limited set of guest operating systems. It's recommended to install VMware tools, and you benefit with VMXNet 3, which is the higher performing network adapter card available. In terms of virtual switch policy, 3 types of policies are available: security policy, load balancing and failover, and traffic shaping. Let's review each one of them in turn. In terms of network policy, in security, you have promiscuous MAC address changes and forged transmits that can be configured. However, as seen in the attached graphic, the default settings usually work in most of the cases. VMware suggests keeping promiscuous mode as reject, MAC address changes at accept, and forged transmits also at accept. These settings allow a normal operation. However, if the organization is very security conscious, it may change any of these settings from the default to allow a higher level of security. If we look into detail, promiscuous mode eliminates any filtering at the virtual network level or at the VM level, and by default the virtual network adapter cannot operate in promiscuous mode. One of the use cases to enable promiscuous mode is if you're scanning for network traffic that's going past the Ethernet. MAC address changes are set to accept. ESXi will accept requests to change the effective MAC address. However, it's set to reject if a MAC address change is identified that traffic is blocked. Similarly, for forged transmits, if there's a mismatch of MAC address, it will be stopped from transmitting. However, in any organization, it's usually set to accept both MAC address and forged transmits. Network policy in terms of traffic shaping: average bandwidth, peak bandwidth, and burst size. Some points to note is network shaping is not turned on by default. It applies to each virtual NIC in the virtual switch. For the standard switch, only outbound traffic is controlled. Traffic shaping is established at either switch level or port group level. However, port group settings will override virtual switch settings. Kilobits may be considered a measure of speed or bandwidth, while kilobytes is a measure of size or capacity. NIC teaming or network policy occurs when multiple NICs are connected to the switch. A team can either share the load of traffic between physical and virtual networks among all of its members, or provide failover in the event of a hardware failure or a network outage. Network policy in terms of NIC teaming and load balancing. There are a number of supported load balancing policies, including route-based, route based on IP hash, route based on source MAC, and route based on physical NIC load. The most common and default is the route based on the originating port ID, and the outgoing link is automatically chosen depending on the port where the traffic is entering, which is determined. The virtual machine's outbound traffic is mapped to a PNIC or physical NIC, which is determined by the ID of the virtual port where the VM is connected. This policy works in most of the cases, and that's why VMware suggests that this is the default policy. In route based on IP hash, the uplink is chosen based on the hash or a combination of the source and destination IP addresses. It has a higher CPU overhead as the IP hash is calculated, but better traffic distribution across physical NICs, especially if the outgoing requests are all going to different IP addresses. This setting, however, requires external network support like Ether channel on the physical switches. Route based on source MAC hash is very similar to the IP hash, where an uplink is based on the hash of the source Ethernet. The outbound traffic is mapped to a physical NIC based on the vNIC's MAC address. And finally, route based on physical NIC load, its most efficient load balancing mechanism, as it is based on the actual physical NIC workload. However, it's only available on a distributed switch. To summarize, we looked at the supported network types, we reviewed virtual switch network and security policies, a quick review of traffic shaping policy, and review of NIC teaming, load balancing, and failover policies. Thank you for watching.